Hi guys, welcome back to my channel Mr. Electron. In my previous video you saw that I removed the high current winding from the armature of this motor that is found in the car exhaust that cools the engine. Okay, so it is free of copper winding. Now I have to replace that thick winding with a thinner one. For that I have this thinner winding. Well guys, the winding thickness as you can see is 0.29 mm. Okay, so this should reduce the intake current to half. I have not planned on deciding how many turns I will give on one pole, but I will give as many as possible with one of these. Okay, if it is like 15 then 15, if it is 20 then 20, if it is 10 then 10. Well guys, now comes the complicated part, the rewinding. So I have placed this mark over here, so I have to choose 4 slots, 1 2 3 and 4. These 4 slots are going to make one pole. Okay, and the copper bars to which the starting and the ending point of the windings will be placed will be these two. Okay, I will use this to show this one and this one exactly in the middle of these 4. Okay, this one and this one. Now it should be in place, so you can see that this copper bar is tied up and it's the starting point, and this pole is the first to create a loop in the clockwise direction with 4 slots, 1 2 3 4. Okay, that's one turn. 2 3. And now it's time to end this pole. So the method for that is like here the turn completes, so this ending wire of this coil will be placed next to this one. Okay, which is this one. So what I'm doing here is marking the point. So this is the point. From here I will have to remove the insulation. Okay, a little sandpaper. Yeah, and we are good to go. Okay, so the first coil is complete, its placement is also complete. Now comes the second coil. Now the second coil is like this was the first slot, second slot, third slot, fourth slot, making one coil. The second slot will start from here, the second coil will start from here, making 1 2 3 4. That's going to be 4 poles. Okay, so you see how I'm placing it. Yeah, well, but before that let's move it a little upwards, and this becomes our second pole. The one next to the starting one is the closing. Yeah, so I've placed the bent mark over here. It's a little bent, which means this part and a little bit up to here, it needs removal of insulation. It's like it is very easy but the only problem is that it's time taking, unless you have of course a winding machine, in which case it is going to be really easy. Well, here as you can see guys, this much is done and the work is in progress. So guys, as you can see that I've completed the lap winding, yeah, and now finally it is time to test it, if it draws lesser current and how smooth it works, and also to check if there isn't anything wrong with the winding. See, it looks proper, but we have to test it obviously. So here what I've already done is I've pushed the brushes back, and there is this small hole in which there is a pin that needs to be placed. Instead I have placed this thick copper wire that is going to keep the brushes in place. Okay, so the first step is to place this armature in this slot. Yeah, done. Okay, now it's time to pull the copper wire. Third one done. The final piece, the fourth one. This is it. Okay, done. So finally all the brushes are in contact with the commutator of this armature. So let's cover it with the field poles and see how it performs. This is a little tricky. The magnets are going to pull the armature inside. Yeah. So finally it's time to test it. So yeah, I'm going to use the same power supply as before. Okay, power supply is on. Okay, well, the shaft is wobbly, but the great news is that the motor is working really nice. Cool. And we also have to measure the current, the starting and running current, which this new winding is drawing. So guys, here as you can see that I have brought down the amps from initially in my previous video you saw the starting amps were around 20 amperes, but now they're only 8 amps, and as it keeps on increasing in speed, and the amps also keep on decreasing. You see, yeah, around 7.87 amperes. Let's place a WD-40 on the upper bearing and see if it becomes even better. Okay, with the hope that it decreases amps further. You see the amperes have actually reduced. Well guys, here as you can see that I've placed this big AC fan, air conditioner fan on this motor, which I'm going to test this with, if it can power it up. Plus, this is my first time that I did the lap winding, although I've done wave windings a few times, but lap winding is completely different. And seeing the results, I'm pretty convinced that I did a good job. Okay, so let's touch the wires. You see, it is working pretty good. Let's reverse the wires. Okay. You see, it is running pretty good. Well guys, as you saw that it was running pretty good in the clockwise direction but not in the anti-clockwise direction, because the motors usually run in the clockwise direction and shape the brushes according to the clockwise direction motion. But when we reverse it, after a long period of workout, it creates an excessive friction between the commutator and the brushes, until the brushes take the shape of the commutator in the reverse direction. So that's the reason why it is running in the clockwise pretty good, but not that good in the anti-clockwise. Okay, so guys, let me know in the comments if you like the motor upgrading videos, and also if you liked the modification of this motor. And now it is drawing lesser current. Initially it was drawing around 18 amps, but now it is drawing only 8 amperes. So you see there is a lot of space still left here, And if I increase the number of turns per pole, which I obviously can because I didn't use too many turns, I gave 25 turns per pole. But now I think that I should have given around 50 or 60 or even 75 turns per pole. Then the winding would be completely filled in the slots, and the magnetic field created per pole would also be huge and at lesser current. So it's still not late. All I have to do is rewind it again.
Now, before moving on with the project, let me introduce you to my new AC-DC clamp meter from Kaiweets HT206D. So here you have got a pretty thick user manual and a big black pouch to hold the meter and accessories. On opening it up, we can see that we have been provided with some cables and batteries and the meter itself. The pouch looks fine too. Now for cables, we have two of them, one for temperature measurement and the other one for the rest of the meter functions.
Next level. Next level.
Now let's turn it on. So here we can see 600 amperes. This is 60 amps and this is frequency and voltage measurement. Okay, frequency on all of them. So let's press this one. We have AC. We have HZ, means frequency, hertz. Next we have the same thing for higher precision, 60 amperes. Same voltage, and for that we will be needing these two pen connections. So it is 13.27 volts. Well, the polarity is wrong. Correct. And now here we can also brighten up the screen with this button. See, and if we hold it for long, see, that's the flashlight. So trying out the NCV function, turning it on and holding it. Now here you can also do the diode, capacitor, continuity and resistance measurement. So at present it is in the resistance mode. Initially mega ohm, now ohm, nanofarad, and that's your diode. Next is the temperature measurement in Fahrenheit and Celsius. Both are available. So let's test it. AC current measurement, and here it is drawing 2.8 amperes, almost 3. So it is at 60 ampere measurement mode right now. DC ampere measurement, 60 amperes once again, and let's place it like this, peaking at 8 amperes. So here you can see maximum 8 amperes and minimum 3 amperes.
When I'm turning the shaft of the wind turbine 3-phase generator, the shaft of the BLDC motor is rotating, but it is also vibrating. But that does not mean that it is not going to work. When taking the situation vice versa, you can see that it is getting not even a single spun in one singular direction. it's vibrating even more in this case.
So guys, let's interchange the wires and then try. But as you can see that it is still vibrating. Let's try rope rotation. Still no change.
When taking the situation vice versa, this motor is showing much more steady spin when compared to the other one.
Still,
It was very tight. Now guys, I also have an e-bike motor and its RPM is almost equivalent to the wind turbine alternator. And there is a great possibility that if we connect the wires of the two machines together, then things might work out. Let's try it. So guys, as you can see that we are pretty close and it's working pretty good, although there's still a little vibration and the shaft gets really tight, but not as much as it got in the previous case. Let's give this motor a spin this time. Nope, not at all good. It was working better in the previous way when I operated the wind turbine alternator and used the e-bike motor as motor. Now guys, I'm going to go with the only option I'm left with, which is connecting the e-bike motor with the e-rickshaw motor and then try. And guys, this way it is working much more better. And also I have not connected the right combination. Here you can see I have connected blue to yellow and yellow to blue. Let's try and connect it properly and then see if it works even better. And guys, I feel like it is working much better now. When I turn the e-bike motor, it is running smoothly, and so is the e-rickshaw motor that is connected to the three-phase wires of the e-bike motor. So the color of the wires connected seems like that also matters. I'm not sure, but it is somehow working better that way. Plus also, there is no surety which motor is going to work back to back with which one. But as far as I think, if we get two identical motors, then it is going to work much more better. I'm still using two different motors. So guys, I have connected this three-phase brushless wind turbine alternator mechanically with the belt and pulley system to a high RPM 4000 RPM permanent magnet DC motor. And with that DC motor, I am going to run this wind turbine alternator, which is then going to generate electricity. And guys, this is the washing machine BLDC motor that operates on 230 volts AC. I salvaged it from that. So what I'm going to do is I'm going to connect the three wires of the washing machine BLDC motor to this wind turbine alternator, and then hope that it is going to run the washing machine BLDC motor. So guys, let's connect the wires of the high speed permanent magnet DC motor to the DC motor speed controller and then test that everything is working fine. So guys, now I'm going to turn on the switch. Okay, you can see that it is working super smooth without any problem. Well, I have few bulbs here. I'm going to try and test it as an electric generator also. Let's go with this 12 volts car headlamp bulb. Wow, you can see such a low RPM and still it is generating pretty good amount of current. Yeah, the wires are getting hot. Okay, so guys, the wires of the washing machine BLDC motor are being connected to the wind turbine alternator. After that, I'm going to turn on the switch to see if it works or not. And this time, after changing the direction of the wires, you can see they fit perfectly to the wind turbine alternator. So starting the setup, okay, go. You can see that it is not running, but it is only vibrating. So guys, this time after turning it on, I'm going to give it an initial push and hope that it starts running. But yes, sometimes things start working vice versa wise. So let's turn this motor and hope that this starts running. Okay. Whoa, now that was something really good. Okay, so what I'm going to do is I'm going to run it this, you see this is running Then start it slowly. Ho 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 ho. Yeah, now I'm getting it. Okay, and yeah, it is running finally. All I have to do is get it synced. Okay, slowly and slowly. Yeah, it has synced. Okay, once again. You see, as soon as it gets synced, it is running smoothly. But as soon as the sync is lost, it stops running. You can see guys that this motor is running and torque is also good. Yeah, pretty good torque. Oh, the belts broke. Now guys, I have finally found the way of running the two BLDC motors back to back. You can see when I'm turning the washing machine motor, the shaft of the wind turbine alternator brushless motor is running pretty smooth. Now this is the back view of the washing machine motor. Somehow I have connected a crank and it is running really smooth, and like the torque needed to run it with this is also not that much. You can see how fast it is running, pretty good. Now this method is not applicable when I use all types of DC motors, which you have already learned if you have watched this video completely. But if you can find the correct partner for your BLDC motor, then it is going to work back to back with the initial one. Hi guys, this what you see is our DC motor 24 volts. And guys, this is a 12 volts high current battery pack for large DC motors. Yeah, it's working. Now although it is working really good, but still I'm not using it for many years. So I'm going to convert it into a high RPM universal motor or AC DC motor. So guys, you can see that the brushes are high quality considering such a small DC motor. And here comes the armature and the pole magnets. So guys, I got these products from Banggood. Link for these will be provided in the description. A few of these, although I'm not going to use these in this project, but yes, I'm going to use this. So here what we have is the center marker for drilling holes, sharp point, plus removable. Once the point gets bad, you can replace this. It's gonna work as new. And these. all titanium coated. Link for these will also be provided in the description. So guys, here I'm going to use these two bolts for this project, not the nuts, only the bolts. And remember that these bolts should get attracted to magnets. They should not be aluminum type. They should be iron or iron alloy type. Let's try these with a magnet. Magnet is sticking. So guys, here as you can see that I have used thin winding, 100 turns on this one and 100 turns on this one. So anyways, let's complete the gluing process. Yeah. Insulation removed. So guys, now the two windings have been connected in series. One terminal will be taken and connected to one of the terminal of the motor, and this terminal is the armature winding, of course. Okay. Now there are two terminals that remain, one from the field winding and the other from the armature. When I will connect a DC supply here, it is going to act as a DC series motor. Okay, because the field winding is connected in series with the armature winding. You see, like this and this. So let's test if it runs or not. Okay, so guys, now I'm going to use this battery to run it. Yeah, you see I have connected, it's not starting. Yeah, the only problem is that initially it was a 24 volts motor, but now because of the additional winding it is going to be a higher voltage motor, somewhere around 30 volts or 35 volts. So let's give it a higher power supply. So guys, this what you see is a 13.3 volts DC power supply. You see, it's running pretty good. Let's see the torque. Yeah, pretty good torque considering a really small motor. Let's increase the voltage further. So guys, this is a 32 volts 5.5 amperes DC supply. So guys, here I'm going to use this power supply to run this motor. Okay, get ready guys. High speed. Really nice. New DC series motor from a PMDC motor at home. So guys, that's all for today's video. Thank you so much for watching it. Please hit like and don't forget to share and subscribe, and if you have any queries you can always ask them in comments. And one more thing guys, it is really important to connect the two magnetic poles accordingly. Like if this is north, then this should be south. They cannot have same poles, otherwise the poles forming inside this case will also be same, and then there will be no repulsion and attraction to create the motion of the armature. So yeah, thank you.